The FANUC CNC display and NDI panels are developed completely by FANUC. Machine tool builders can customize some of the screens and add new value-added screens, but the hardware and basic software is pretty consistent across all machine tools. In contrast, the machine operator panel is almost always developed by the machine tool builder. It interfaces to the CNC system using a FANUC interface board, but all the switches, push buttons, indicators, lights, power meters, and other devices are provided by the machine tool builder. FANUC does produce some generic machine operator panels that are used by smaller machine tool builders, specialty machine tool builders, and CNC retrofitters. Even those FANUC operator panels are fully customizable by the machine tool builder. It should be easy to appreciate that a simple 2-axis lathe requires a much simpler machine operator panel than a complex machining center, so each machine tool builder may have a variety of operator panels for their machine lines. With this in mind, it's impossible to provide an overview of the machine operator panel in the same way that we provided an overview of the FANUC CNC display and NDI panel. There is no point going through one particular operator panel in precise detail because it will not fully translate to the next machine operator panel. So in this overview, we will discuss the base functionality that must be available on most machine operator panels to achieve basic part program and machine operation. We have to refer to the machine tool builder's operator manual to learn about the buttons, switches, and lights that may be available on a specific machine tool. Though the machine operator's panel is developed by the machine tool builder, many of the buttons, switches, and lights provided are a necessary component to run every FANUC CNC. These elements must be integrated with the machine tool features for safe operation. For example, cycle start is the button that the operator presses when they want to execute the selected part program. FANUC cannot predict all the situations that must be checked on a particular machine tool to determine if it's safe to allow the cycle to begin. There will be door interlocks, operating pressures, machine mechanism positions, and other things to check. So when the operator presses cycle start, it is detected by the PMC or programmable machine control. Software written by the machine tool builder checks all the machine systems and determines if it's safe to start the program or not. If not, hopefully a warning message or alarm is displayed and the cycle start request is ignored. If everything is good to go, the machine tool builder's software tells the CNC to start the cycle. For this tutorial, we will use this generic machine operators panel, an implementation of one of the generic machine operator panels available from FANUC, and it also includes most of the basic functions to run a program. One item it does not include is a handwheel or MPG, which is an abbreviation for manual pulse generator. The handwheel is an ideal way to manually move the axis, and it works pretty much like a handwheel on a traditional machine tool, except the connection to the axis is electronic fly-by-wire rather than mechanical. They are particularly useful for setup, allowing rapid, slow, and precise movement as required. The buttons, switches, and indicator lights on any machine operator panel are typically organized into logical groups for ease of use. On this machine operator panel, we have the CNC mode buttons, the program control buttons, the axis manual jog buttons, increment buttons, the cycle control buttons, and some machine feature buttons. We also have switches and buttons to override the feed rate, rapid rate, and spindle speed. We can see there are more blank buttons and lights available for the machine tool builder to add additional machine functions. Down here we also have the emergency stop or e-stop button, the edit protect key switch, and the CNC on-off buttons. We will start by looking at the CNC mode buttons. Setting the appropriate mode is the first step in most operating procedures, since selecting the CNC mode determines much of what can and cannot be done on the CNC or machine tool. If we want to run a program, we must be in one of the program modes, auto or remote mode. If we want to jog or move the axis manually, we must be in one of the manual modes: jog, increment, or handwheel. The CNC can only be in one mode at a time, so the first thing to note is that selecting a new mode always deselects the previous mode. So if we have auto mode selected, as indicated by the light above the push button, pressing the Edit Mode button selects the edit mode and deselects the auto mode. The same goes for all the other mode keys. This is very obvious when you select mode with a rotary switch. The switch can only be in one position or one mode at a time. Besides the light above each mode push button or the position of a rotary switch, the CNC indicates the currently selected mode in the status bar. Auto is indicated as MEM or memory mode, Edit as edit mode, MDI as MDI mode, Remote or DNC is abbreviated as RMT, Ref, reference or home mode as Ref, Jog is Jog, and Inc or incremental mode is Inc. Though the CNC does not have a hand wheel, Handle or MPG mode is abbreviated as HND. We will take a close look at each of these modes. Auto or memory mode is used to run a part program. With a part program selected and with the CNC in MEM mode, when we press the cycle start button, the program will be executed. The program will be executed continuously until it reads a program stop code or is stopped manually by the operator. Several of the other buttons on the machine operator's panel work with memory mode. Cycle stop is sometimes labeled feed hold or just hold. Cycle stop temporarily pauses the program. The hold condition is indicated in the status bar, and with this example machine operator panel, the cycle stop light also flashes. The CNC stops the axis in the middle of the current move. See, we still have a distance to go value here. To release the hold, we press cycle start again. Program stop is active whenever an M00 program stop command is executed. The stop condition is indicated in the status bar, and with this example machine operator's panel, the program stop light also flashes. In this case, the button has no function, it's only a light. We cannot see the M00 code in the program display because it's already been executed, but you can see that the last M code executed was an M0. An M0 is often included in the part program to stop the machine so the operator can perform some functions before continuing. It could be tool maintenance, make a measurement, rotate the workpiece, or many other tasks. In this case, the program includes a comment to instruct the operator to clean chips from the workpiece before continuing. To continue and release the program stop, we press cycle start again. Now we have reached the end of this short program, and it's automatically rewound to the beginning. That is because the last statement in the program was an M30 program end and rewind. Except for the M00 program stop, all the blocks were executed in sequence automatically. Single block executes just one block each time cycle start is pushed. Some complex cycles, such as CAN cycles and the G28 return to the reference position, are like subprograms, and it may take several pushes of cycle start in a single block to execute the complete cycle. After a block is executed, a stop condition is indicated in the status bar, and with this example operator's panel, the single block light changes from continuously lit to flashing to indicate to the operator why the program is stopped. We can execute the whole program in single block if we like. To return to continuous automatic operation, we turn single block off. Next time we press cycle start, the program will continue from the current block to the end of the program. Optional stop is active whenever an M01 optional stop command is executed in the part program and the optional stop button is active. The M01 optional stop code is similar to the M00 program stop code. The difference is that the program will only stop at the M01 if the optional stop button is activated on the machine operator's panel. In this program, we see an M01 code after the Start Tool section in the program. The Start Tool section includes safe start blocks, selects the tool, starts the spindle, and moves the axis to an approach position. If we press the Optional Stop button, the light turns on to indicate Optional Stop is active. When we press Cycle Start, the program runs until the M01 is executed. Again, a stop condition is indicated in the status bar, and with this example machine operator's panel, the optional stop light also changes from continuously lit to flashing to indicate to the operator why the program has stopped. It is very common to include an M01 at strategic points in the program, such as tool change points or at the beginning of an operation. These can be helpful when initially verifying a program, or to stop the program before some process maintenance, such as inspecting a tool and checking the coolant levels. In normal operation, the optional stop button is turned off, but the operator can turn it on at any time they want to stop the program at one of the safe stopping points. The operator could of course press the Cycle Stop button at any time, but the Cycle Stop may halt the program in the middle of a move and break a tool. Optional Stop provides a better method for stopping the program in a more controlled way without any incomplete moves. To continue, we turn off Optional Stop and press Cycle Start. Block Skip skips over any blocks that begin with the block skip character. To demonstrate block skip, we'll open a new program. This program has two operations. Note that all the blocks from the Start Tool 5 through the second Tool Stop Code section have a backward slash character at the beginning of each line. This is called the block skip or block delete character. All the code associated with the second operation is marked with the block skip character. Let's turn on Optional Stop to help us see what happens. When we press Cycle Start, the program executes up to the first M01 and stops at the beginning of Operation 1. When we press Cycle Start again, the program executes up to the next M01 that is just before Operation 2. Pressing Cycle Start again completes the program run. Now we press the Block Skip button to turn on Block Skip and press Cycle Start again. The first part is the same. We stop at the Operations 1 section. But now when we press Cycle Start, the CNC performs the Operation 1 blocks and then skips over all the lines with the block skip character and jumps to the end of the program section. There are many applications for block skip in manufacturing. Warm-up or setup code at the beginning of a program, optional operations on the workpiece like the example we just demonstrated, trial cuts, thread sizing, and more. Machine lock runs the program without actually moving any of the axis. See that the absolute, relative, and distance to go positions are changing to tell the operator what should be happening, but the machine position does not change. Running the program in machine lock allows the CNC to detect any syntax errors in the program, allowing the operator to test the program without any chance of a collision. Note that all the axis position values are preceded with the highlighted L to indicate that the axes are locked. Some machines will have a Z-axis lock button, which only locks the Z-axis, allowing the operator to visually check the XY positions for each move without bringing the tool close to the workpiece using the Z-axis. Dry run processes interpolated moves at the rapid rate, ignoring the feed rate specified in the program. The machine tool builder will likely prevent coolant from running during dry run. This machine operator panel has these rapid override buttons that modify the feed rate to a percentage of the maximum rate. Machine lock, Z-axis lock, and dry run are used during power program verification. Restart is a function that allows an operator to start a cycle from the middle of a program. This is particularly useful when executing large programs and the program has to be interrupted for tool or machine maintenance, or a plant shutdown over a weekend or holiday. The restart function searches through the program and finds all the M codes, T codes, and S codes used up until the search point. When restarting, the CNC executes all the M, S, and T codes in sequence without moving the machine axis. Then the axis moves to the coordinated position specified in the program. You must be sure to manually position the axis so that the move from the current position to the restart position will not pass through the workpiece or work holding and cause a crash. To continue from this point, we must release restart and press cycle start. The program continues with all the correct MS and T codes activated. Two more controls that are used in memory mode are the manual feed override, or MFO, and the spindle speed override, or SSO. The feed rate override modifies the program feed rate by the percentage indicated by the selector switch. So if the feed rate override is set to 100%, the actual feed rate will be that specified in the program. If the feed rate is set to 50%, then the actual feed rate will be half of that specified in the program. Similarly, the spindle speed override overrides the program spindle speed, but it only goes down to 50% for safety reasons. Operators may override the feed rate and/or spindle speed to solve a tooling issue. Some operators use the feed rate override as a kind of accelerator when testing and verifying a program, slowing the feed rate down considerably as it approaches the workpiece, and speeding up when they're sure everything is correct. The rapidly positioning move can also be very intimidating for an operator verifying a new program. Therefore, there's usually some way to independently slow down rapid moves. It may be a selector switch similar to the feed rate override. In this case, we have 4 switches setting the rapid rate to 0, 25%, 50%, or 100% of the machine's normal rapid rate. Before we leave memory mode, if we press the Operation soft key in memory mode, we see operations such as Program Search, one way to select a program, Sequence Number Search, and Rewind. P-type and Q-type are associated with Restart function. The next mode is Edit. If we select Edit mode, we can edit the program. Note that the Operation soft keys change. Also, though we can view the program in either the program page or the program check page, we can only edit the program on the program page. Program editing may be protected with a key switch on the machine operator panel. More on basic program editing in a later tutorial. MDI is the abbreviation for manual data input. As we switch from auto or edit mode to MDI mode when on the program screen, the active program disappears and we see a program automatically named 00000. In MDI mode, we can enter a temporary part program right at the keyboard and execute it immediately. It could be as simple as programming a single M code to start the spindle, or a multi-line program. The key point is that once we press cycle start to execute the MDI program, it is erased. An MDI program is never saved. You can enter and edit MDI program statements in the key input buffer before committing them using the insert or input key. After that, you can edit the program on the screen just like a regular program, inserting, altering, and deleting words. You can execute the program just like a regular program, from the beginning to the end, or step by step in the single block mode. but once the end of the MDI program is reached, the program is completely erased. MDI mode is very useful for setup and maintenance, where you may want to execute a particular machine function without committing to writing a permanent part program. Many of the program control buttons will also work in MDI mode, but outside of single block, they have no practical use. Note that MDI mode is also required to change some CNC settings and system parameters. More on that in a later tutorial. Remote mode is sometimes called DNC mode. In DNC mode, programs can be executed from a remote device, such as a network drive or memory card. The primary benefit of remote mode is that larger programs can be executed, programs too large to fit into the CNC part program memory. This technique is often referred to as drip feeding a program. Whereas the internal part program memory may be limited in the CNC to 512K, 1 megabyte, 8 megabytes, or perhaps 16 megabytes depending on the FANUC series and installed options, memory cards are available that support gigabytes of data, and a network connection may be considered limitless. For example, to run a program using DNC from the memory card, we must change to the memory card device. First, we select the program folder. Next, we press the Operation soft key. Next, we press the Device Change soft key. In this example CNC, we have three choices, and it's a bit confusing that two of them are labeled Mem Card and Memory Card. The one we want is the full spell Memory Card. Once that is selected, we can see a list of the programs available on the memory card. We highlight the 1231 kilobyte program O1051. Next, we press the DNC Set soft key. Note a letter D now appears next to that program, signifying that it is the DNC program. When we go back to the program or program check page, we might expect to see the first blocks of the program, but the display is blank. This is because when we drip feed, nothing is loaded into the CNC until we press Cycle Start. It's a good idea to switch to single block mode before pressing Cycle Start so you can see the first few blocks of the program and check it's the correct one before continuing. Note all the comments are stripped from the program in DNC mode, so you cannot use comments to identify the program. When we are sure, we can release single block and press Cycle Start to continue executing the program. FANUC has a more robust solution for large programs called Data Server, but DNC from a memory card is a good solution for a manufacturer that has the occasional part program that does not fit into the available internal part program memory. Reference or home mode is less important with today's absolute feedback devices. On legacy machines, axis reference was the first step to be performed every time the CNC was turned on. This establishes a machine coordinate system. It typically involves initiating a reference cycle where an axis moves in a specified direction until a reference switch is tripped. Today's battery-powered absolute encoders monitor axis positions even when the main machine power is off. Even if an axis is moved mechanically, the feedback device detects the new position. Now the only time the axis needs to establish a reference point is during installation and then whenever the batteries are replaced with the machine power turned off. The reference position is often referred to home or the home return position. It is still a common practice to send all the axes to their home positions before powering down a machine as a matter of good housekeeping. The axis can also be returned to the home position under part program control using the G28 cycle. Some machines have a single button to return all the axes to their home positions. Others are required to return axes one at a time. Many machine operator panels have lights that indicate if the machine is at the home position. This may be driven by a proximity switch or by checking the CNC machine position with the FANUC software position switch feature. Check the Machine Tool Builder's operator manual for specifics on the reference or home feature on a particular machine tool. With this particular machine operator panel, you can return an axis to its home in ref mode by selecting an axis and holding down the minus jog key until the machine position is 0. Note that the axes move at the rapid rate. From a maintenance perspective, the home or reference position is the origin or 0 point of the machine coordinate system. Both absolute and relative positions may be changed by the operator or the programmer as required with a variety of offsets, but the machine coordinate system and the machine 0 is always the same. Jog or continuous jog mode moves an axis as long as the axis button is depressed. A popular configuration is to have one button to select the axis jog and then a plus and minus button to actually perform the jog. So here we have the x-axis selected. Pressing the plus button jogs the x-axis in the positive direction. Pressing the minus button jogs the x-axis in the negative direction. Pressing the Y button selects the Y-axis as the jog axis. Now we can move the Y-axis using the plus or minus jog buttons. Incremental jog mode is very useful for setup if a machine does not have a hand wheel. It allows an axis to be moved a precise distance using the jog buttons. Again, the X, Y, and Z button selects the axis to be moved. The increment button sets the distance that the axis will move each time the jog button is pushed. In this particular implementation in inch mode, X1000 moves an axis 100 thousandths, X100 moves an axis 10 thousandths, X10 moves an axis 1 thousandths, and X1 moves an axis a tenth of a thousandths. The plus or minus button again initiate the actual move. So if we select the increment mode, select the x-axis, set the increment to X100, pressing the plus button moves the x-axis in the positive direction by exactly plus 10 thousandths. Pressing the minus button moves the x-axis in the negative direction by minus 10 thousandths. So incremental jog can be used to finely touch off a tool from a measurement surface. Handle mode is the optimum tool to move the axis manually. A hand wheel has a number of graduations and may provide an audible click for each increment of the graduation. The distance the axis moves for each increment or click can also be set with the increment buttons. So with a large increment selected, the axis will move fast as the hand wheel is turned. With a small increment set, the axis will move very slow, providing the fine adjustment required for precise and safe setup. If available, most machines will only have a single hand wheel. So again, the X, Y, and Z buttons may also be used to select the axis to be moved. And then the CNC mode determines if the movement is continuous jog, incremental jog, or the hand wheel. This machine operator's panel has a few machine buttons. Coolant can be controlled by M08 and M09, and the lights indicate the active code. If the program code is overridden by manually stopping or starting the coolant, the light flashes to show the manual override condition. The spindle buttons and lights work very similar. Many machine operator panels will have many additional standard and optional push buttons, switches, and lights for a variety of machine features. Here's a machine operator panel from a small lathe. Again, we have the e-stop button and the spindle and axis override switches. This panel does not have CNC on-off buttons, as power is applied directly from the main machine electrical breaker. Here again are our 8 CNC mode buttons, the program control buttons, the axis manual jog buttons, an increment select button, the cycle control buttons, and a few machine feature buttons. Over here on the right is a hand wheel, or MPG, to jog the axis, with selector switches to choose the axis to move, and the increment distance to move per click of the hand wheel. Here's another example of a small lathe. Here we can see the mode selection is achieved with a selector switch rather than a series of push buttons. This machine operator panel has separate axis feed rate override and rapid move override switches. It also has a lot more machine feature buttons. Here's an example of a 5-axis machining center operator panel. Here are the mode selection keys. The H is for hand wheel. Here are the program control buttons. Here are the axis jog buttons and increment buttons. Here is cycle stop and cycle start, but in this case they have labeled cycle start appropriately as action. There are several machine feature buttons up here. Here is the control on and off buttons, and here is the hand wheel. We can see there is a large variety of machine operator panels design available, and practically every machine builder will be somewhat unique. In this tutorial we have only focused on the common functions. This completes this tutorial on an introduction to the machine operator panel.